So we have to discuss the assignment part and the problems, right? Hope you have gone. So shall I directly go for the content? Okay. So first one, we have to have a detailed knowledge on A minus B. So let me go to the board work. So on A minus B, we already know that A minus B and B minus A are not both the same. Okay. We have to know all these things. And if we take the help of the Venn diagram, if we take the help of the Venn diagram, I take this as a universal set or the sample space A and B. A minus B is this area alone, which means from this Venn diagram, make yourself very sure that B will not be present. Okay, we have discussed this in detail. Okay, how we read this one? A minus B is read as only A. As of now, I have not discussed in detail because if I talk about this A minus B on three sets, only A means only A but not B and C because I have three sets A, B, and C. So, if I talk about only A means I'm not talking about B, I'm not talking, which means I don't want B and I don't want C. So, I should not have elements on B and I should not have elements on C. But when I say only A but not B, what happens here? Only A but not B. In this case, I may have C. See, there's a lot of this point I have so far I have not discussed this point. So for this convenience sake, let me take the Venn diagram. Okay, for this third point, let me take the Venn diagram. So A minus B is only A, but not B. Actually, it's not, but not B. But we are considering only two sets A and B. We can say this is only A. But if we are considering three sets, so on three sets, A minus B is only A, but not B. Okay, if I talk on three sets, A minus B intersection C will be only A, which means it's understood there is no B, there is no C. So let me go for this Venn diagram on three sets. Okay, if it is on two sets, you're comfortable, I think. So this is A, this is B, and this is C. Okay, my marking is for this one, which is A minus B, only A but not B, which means I can have C. C is not mentioned, which means I can have C. Okay, so please check whether this marking is right. See, I'm covering C here. We had to focus on this. I'm covering C. C is allowed. C is allowed. Let me go for this one. I have A minus B intersection C, which is read as only A. Actually, will not call this one as A minus B minus C. It doesn't have this type of a relationship. We can call A minus something. So A minus B intersection C is only A. So if I have A, if I have B, and if I have C, then A minus B intersection C. Okay, let me go first for B intersection C. If I shade B intersection C, which is the shading? Is it right? B intersection C. Okay. Obviously, now I'm going to remove A minus B intersection C, which means this B intersection C should not be present. And obviously, I'm not going to consider C also. So this one also should not be present. So my shading, probably I'll go for dots. So this is going to be my A minus B intersection C, which is read as only A. Okay. So not to confuse you, let me have only A, which means I'll be having this one above. Okay. If you compare these two, see, I'll be having this region because it's only A but not B. B should not be present. What about here? It's only A alone. B should not be present. C should not be present. So this is the third point. Okay. Let me finish off the whole content. Then I'll give you some time. You can please make a note of it also. So this third point. So from here, I have finished these two. Is it okay? Uh, C. Yeah. A minus B intersection C can also be written as A minus B intersection A minus C. Okay, so let me go for the Venn diagram in this angle. A minus B intersection A minus C. Okay, so what is over here? I'll draw. Please tell me. This is A. Okay, I have to take it smaller. This is A. This is B. This is C. I will talk A minus B first. Yes, A minus B, C will be present. Alright. Now let me talk A minus C. Yes. Let me take some dots like for differentiating. So this is completely shaded. We are not going to focus on shading and all because we're not going to write these things in the exam. So now A minus C. What is A minus C? B will not be present. Sorry, C will not be present. So this A will be present and this will be present. Okay. Now we are talking about A minus B intersection A minus C. See this one. This one can also be written as this one, right? A minus B intersection. So I have taken this one in red shading. I have taken this one with black dots. I have to intersect this one, which means common between these two. So I can take this one. Am I right? Please check. See this area, right? See, this is the area, which is nothing but only A, no B, no C. So only A means is understood as only A, but not B, but not C, but not B and C. We have to be very careful of this, okay? Because you cannot expect this as a direct statement. If there is only A and B, then it's very clear. Only A means, but not B. If you are talking about three sets, A, B, and C, then you have to be very clear that only A means no B, no C. Only A, but not B means C is present. You have to be very clear. So this one is done. This complete set is done. And we have done with this one. Now go for the second one. Did you try working this with Venn diagram? Did you try working with this Venn diagram? I gave you an assignment. Okay. I don't know how far you tried. If you have not, if haven't tried now, I request you to do it as an assignment. Okay. Finish it off because I'm not going to go in detail. Let me go for these two. I'll explain the other three in general. A minus B can be written as A minus A intersection B. Okay. From the Venn diagram. Okay. So this is my fourth point. So this is my Venn diagram. I'm going to talk about it only on A and B alone. So this is A. This is B. Please tell me which is A minus B. This one alone, right? Okay. What's my first point from your material? A minus A intersection B. Please check whether this is right. The shading and this one equals is the same. A is the whole of A round. Okay. A intersection B is this common region which you are removing. This obviously is right. What's the second point? Yes. A union B minus B. Okay. A union B minus B. Okay. A union B first, then minus B. A union B, which means you'll go for full complete shading where you have to remove complete B, which means you will remove B. So what will be existing? The same shading. Okay, so I'm not confusing with the shading. So this will happen. Third one, A intersection B dash. Can please guess A intersection B dash. Which is B dash? I'll go for the Venn diagram. Which is B dash? This is A. This is B. B dash is this one. B dash is not in B, right? What is B dash? How do you read B dash? Not in B. So you now intersect A. A is this full circle, but we cannot take full circle because intersection part means we cannot take about this area. So obviously this will match with this diagram after intersecting with A. So your diagram will have this shaded area alone, shaded in black. Third one done. Now fourth one. With the help of del. What is del? A minus B union B minus A. So let me have it written here itself. A del B is A minus B union B minus A. Okay. Minus B minus A. Obviously, this will removing this one. So this is gone. And this one. Universal set. Yes, it's a beautiful case. So fourth one done. Fifth one. Universal set minus A minus B the whole dash. This I have to go for a small working. Fourth one is A. This fourth one, it's A del B minus B minus B. Is it okay? Now fifth one, we are talking about universal set minus A minus B the whole dash. What is A minus B? From the Venn diagram, this is A minus B. Okay. Now I have to talk A minus B the whole dash. I'll make it in dots. Okay. This complete area, right? Am I right? This whole thing will be covered. That is, instead of the red shaded region, everything falling outside that will be A minus B the whole dash. This is the universal set, the complete set. Sometimes we may be talking about sample space. Whether it's universal set or sample space, we have to decide then and there. Okay. If universal set is given, first priority for universal set only. Okay. Else there will be some mentioning, even though universal set is given, there will be some mentioning not in the set form but in descriptive form. It will be given in words. Okay, this A minus B has to be taken from the sample space. You have to be very clear in that. Okay, so this universal set, and from this you have to remove the black dots. See, this is the black dots. A minus B, the whole dash is black dots. From universal set, if you remove the black dots, and you can be very clear, this will be the region. So this is the fifth case. So we have different 5 cases where instead of writing A minus B as A minus B directly, you can take the help of intersection, you can take the help of union, you can take the help of complement, you can take the help of del, you can take the help of universal set also. So using the different operations, we are presenting A minus. Okay, again let me finish it off. Now what happens is, when I talk about cardinal number, A minus B, if I talk about n of A minus B, you cannot directly write as n of A minus n of B. It's an abrupt mistake. You should not do it. It's often repeated exam point of view. Okay. Because if I take the help of the first expression A minus A intersection B, I can write here as n of A minus n of A intersection B. See, here if you do it this way, you're completely removing B. See, what is n of B? You're completely removing B. Here B is not completely removed. What is overlap? That only we are removing. Okay, see, you're not worried about this space, am I right? See, you're not worried about this space. I'm not completely removing B. From B, I'm removing B. So that's the definition which says A minus B means A is there. If any elements of B present in A, you're removing from it. So you should not take here this one. Instead, you'll be taking n of A minus n of A. What happens in the second case? Let me take this space. Please tell me. You know the addition theorem? N of A union B is equal to n of A plus n of B minus n of A intersection B. Is it okay? Now consider this one. N of A union B minus B, which is n of A union B minus n of B here. Okay, you take the whole of B, right? Now what happens? What is n of A union B? Yes, n of A plus n of B minus n of A intersection B. Now this n of B, okay, this n of B, this n of B and this n of B will get cancelled. So ultimately you get n of A minus n of A intersection. We see you're getting the first one. So ultimately you can write this as n of A minus n of A intersection B. Is it okay? So you have to take note of all these points. But when you talk about A minus B can be on 2 sets. A minus B can be on 3 sets. Okay, 2 sets and 3 sets. You have to be very keen on this. And remember that, and this one, n of A intersection B is being removed. That's why n of A minus n of A intersection B has to be considered. Yes, if you want to make a note of it, please. Okay. Moon angle எழுதலாம். Can write it in 3 angles. First one for only A. I'm writing this only for A, only A. Which means there is no B, there is no C. It's understood? One way of representing is A minus B union C. Another way of representation is A minus B intersection A minus C. And third way of representing is A minus A intersection B intersection C. See, you check this one. If I take the box, this is A, this is B, this is C. A is full circle A, and I'm removing the common area. See, this is a common area. I will not get this one also. Okay, so this is not A intersection B intersection C. This is A intersection B. Okay, we'll leave this one. Need not worry. Only two ways. You can just make a note of these two ways. Okay, please make a note. Check whether this Venn diagram is okay. We go to the second one. This is only A because only A and B are present. So this can be called as only A. So A only is present. This is B only is present, which means this area. Okay. This common region is A intersection B, which you call it as A and B. See, in this diagram, we are focusing on bodies. Okay. And please try to recall this one, neither A nor B, which is just the opposite of either A or B. When I say either A or B, it is about A union B. When I talk about neither A nor B, it's not in A and also not in B. Not in A, not in A, and not in B. Am I right? Not in A means A dash. And it means intersection. Not in B means B dash. See? Okay. And also, if you take the help of D Morgan's law, you know D Morgan's law, probably I don't know how far you can recall, but I've done it in the school days. A union B the whole dash can be written as A dash intersection B dash. This is one D Morgan law. The second one is A intersection B the whole dash can be written as A dash union B dash. If you have union here, you will get intersection here. If you have intersection here, you'll have, and this complement operation will be taken together outside for both A and B. So if you check now here, A union B, the whole dash is neither A nor B. So A union B, the whole dash is neither A nor B, which can be written as A dash intersection B dash. Okay, so this is one. And if you go for this diagram, the first set, this region is nothing but A minus B union C. Okay, so that's what I was trying to say here. I was correcting here. This is not intersection, this is union. Okay, so this is A union, sorry, A minus B union C. This is only A, which means no B, no C. This one, only B. So only B can be written as A minus, sorry, B minus A union C. And this will be only C. Okay, what about this one? The innermost common region. Can call this as A intersection B intersection C. Intersections and so A and B and C, which means all the three present. So common, all the three present. So probably we may find it like these terms. Number pass in mathematics, number pass in accounts, number pass in commerce. So how many pass in all the three? We will go for the problems. Probably I think there's a third problem. Okay. So common to all the three, which is pass in maths, pass in commerce, pass in accounts, all the three, which means this is the combination. Okay. What about this area? A intersection B minus C, which means present in A and B, but not in C. See, whenever you have this minus, it is giving a condition, but it's not present. Okay, so present in A and B, so A and B, but not in C. Not in C. Like this, you can write this one. Present in A and C, but not in B. That's it. Not in B. Likewise here, present in B and C, but not simple problems. First one, which one is correct or incorrect? You will not get this type of problem, which means you may not get this as the heading. Which one is correct or incorrect? You may not get this one because four options will be given. You have to write the correct one or the wrong one. So you not have this type of heading because I am having many subdivisions I have written this. Before going for the first problem, if you please make a note on the symbols. First one has epsilon, which means belongs to. Okay. Second one has does not belongs to. Okay, I'm not writing each and everything. We have this one, which is no, this is subset. This is proper subset. Okay, I should not have equal to. Proper subset means cannot be equal. Okay. Then this is epsilon and this is does not belongs to. And please make a note whenever we talk about this symbol belongs to, we are talking that the element which is present here should that is we are talking about the element or the member of the set. Okay. When we talk about this one, we are talking about subsets and proper subsets. Okay. So let me go for the first one now. Yes, you can please join. First one, probably you might have done working on this as an assignment, so I can take up the speed. Please make a note of the first one. 3 belongs to 135. Before confidently saying this is right or wrong, check what is present over here. Usually, how the sets representation is done. Remember how we represent a set? A equal to, so it need not be A always, it can be B or whatever it is. You represent by a capital letter, open the brackets, close the brackets, separate by commas. I was earlier saying that this need not be curly brackets, it can be normal brackets. So here in this case, we have normal brackets. And this is a set which contains 1, 3, and 5. So 3 belongs to epsilon symbol says belongs to. So 3 belongs, yes, this is one is right. Correct. If I go to the second one, I have a set which contains only 1 and 5. Okay. And 3 does not belong. Yes, this is also right. Correct. If I go, let me finish it off. If I go for the third one, it has a set which contains 1, 3, and 5. Okay. So you always go from the back set. Okay. So this is a set which contains 1, 3, and 5. And here is a singleton set, which is represented by bracket. It's not an element. 3 is not an element. 3 is a subset. Okay. And we are using this symbol, which means it can be a subset or it cannot. Actually, when I have equal to, we are talking about subset only. So this is also right. Correct? Am I right? Or actually can represent this one also. Because it's a proper subset, right? I can represent this one also. This one is also equally right. Because if you find in the exam, this one is right. If you find it here, this one is obviously right. Because this is a mention saying it's a subset. If you find two answers, like this is the question, you find option A, B, C, D, you find that one answer saying this one and one answer saying this one, then B is strictly right. Okay, see, you're in professional course, you're not finding the right answer, you're finding the very closest answer. Please try to understand that. You're not going to say this is right or this is wrong. There's a question, you're trying to bring the closest answer. So this one is right or this one is right. If both of the symbols are given, this one is right. If the symbol is not present, obviously this one is right. That's why I have made this one as a symbol here. So you can please make a note of this one. Then D, yes, this is right. This is a set. This is a subset. So if I talk only about 3, I can say 3 is an element. Here I cannot say 3 is an element. Is it okay? So this is right or wrong? Wrong. Okay. What about E? Actually, this is a wrong representation. Okay. Probably you can another add one F1. Can add F1 also here. So this is my question. 3 belongs to 1, 3, and 5. Please try to understand. So this is a set which contains sets. What's a singleton set? 3 is a singleton set, 5 is a singleton set. Now you can write belongs to. This is correct. Actually, you cannot say this is incorrect. This is actually a wrong presentation. This presentation cannot come. This is a wrong presentation. So probably you may not get this type of a question. If it is asked, if you cannot give the answer as wrong presentation, you write it as incorrect only. Okay. Yes, sir. Can please make second question. Fill in the blanks. So you're sure about these symbols now. Okay. The last one is equal to. First one, 3, 4. Go from the reverse direction. 3, 4 union 4, 5, 6. So this will have 3, 4, 5, 6. Even though 4 is present twice, we'll take only once. So we are talking about the singleton. It's not a set, it's a single element. So you can have epsilon. I go for the second one. Second one is over here. 5, 6 intersection, 6, 7, 8. Yes, intersection. It's present in both the elements. Okay. Now we are using this as a not element but as a set. So how it looks like is first one we did as union, second one we did as intersection. So automatically your mind will be working as epsilon. Okay, it's not, it's a set here, singleton set here. So not to tell me the symbol, the symbol. It's a proper subset. So I can strictly use this symbol. Okay. Third one, 3, 4, 5. Sorry, 2, 3, 4, 5. So obviously this is containing only 2, 3, 4, 5 alone. And we are talking about 3, 4, 5. Yes, it's a proper set. Fourth one, yeah. Yes, please tell me this one. A, B, and A. Actually, this is a superset. You remember? A7 is a A7 or A6 or whatever the subset of A, or A contains A6. So I'll have this symbol. You may ask, ma'am, you did not give the symbol over here, ma'am. What I claim only, I did not give it. Okay. So you have this ulta. Because this is a big set and this is a superset and this is a subset. Okay. And fourth one, sorry, fifth one now. Fifth one, 3, 5 union, 5, 6, 7. I don't have 4 here. So does not belongs to. Make yourself sure. And what about this one? It's 1, 2, 3. Right? If there is a repetition, you should not repeat it. It's 1, 2, 3. And over here, it's 3, 2, 1. So obviously this is going to be an equal set. Okay. Yes, please join. Third one, A union A is equal to A itself. Probably if you make a note of the options given, you'll find A union A is A itself. Option is A. Unfortunately, I given E because just to confuse you. Usually, what we say is go for all the options because we are not finding the answer, we're finding the closest answer, very best answer we are finding for. So, E unnecessarily I have given. So, you need to know that unnecessarily to confuse you, some extra data may be given. Okay. Fourth, A intersection A is A itself. Okay. Yes, fifth one, A union B the whole dash. De Morgan's law. Just now we were discussing. A dash intersection B dash. Done. Sixth one, A intersection B the whole dash. A dash union B dash. Okay, see if you make a note of the first one, you'll find A dash union B the whole dash. It's wrong. Basically, B's answer. Seventh one, yeah, hereafter we'll say that E, there is something called as E, which is a superset. Okay, so if you have a diagram like, you'll find it like this way. If you put it this in the Venn diagram, C is a superset of E. Okay. But sometimes what happens is it need not be a proper set. Anyway, we are not going to confuse much. What is given here? A union E. What is A union E? Union. You get the whole thing, which is E itself. Which is option. Yeah, E itself. A intersection E. So this is your diagram. This is A. This is E. What is A intersection E? A itself. See, you remember that one page we did with all the 5 cases? That Venn diagram, that one, you have to recall all those things. So you have to get this picture in your mind. Okay, what is E union E? We should not write it as 2E because what we say is union is associated with the symbol addition. Intersection is associated with the simple multiplication. So when we have union, E plus E will be as a representation or not? No. Whenever we take N of E union E, you can write it as N of E plus N of E. That's about cardinal number. See, this plus and multiplication symbol is arithmetic operation. Okay, so you cannot write this as 2E or E square. We should not present this way. E union is E itself. Okay, I'll place a star mark, which means you have to make a note of it. Then what? A intersection E dash. Beautiful, right? See, this is A. This is E. Okay. First, you have to focus on E dash, which is the outside area. So, A intersection E dash, there cannot be anything common. Alright. So, it's going to be null set. Hope it is okay. 11th one, A intersection, null set. Null set means nothing present. A intersection null set means there cannot be anything common. Okay, so null set. A union A dash. Yeah, A union A dash. Actually, if you recall the figure, it may look like this. This may be A and this may be A dash. So this is the superset. Actually, we name it as sample space S. Here superset E is given. So we take it as E itself. So this will be your diagram. So A union A dash will be the whole as E. Okay, please make a note of this one. Okay. This is not only for this case. This is in general A union A dash will be the whole of. So till this is one set. Please make a check whether you can follow till 12, problem number 12. So you have natural numbers or what you call as counting numbers. Am I right? Natural numbers, you know, repair, counting numbers. It starts with 1, 2, 3. It's not ending, infinite. Along with this, if you take 0, you will call this as whole numbers. So if you have the number like 0, 1, 2, 3, etc. So this one is counting number. Along with this, if you take, you will call this as whole number. Okay. Which has only positive values. And 0 has, whole number has 0 and positive values. Along with this, if you take negative numbers, we'll call this as together integers. So probably we may be using the term as a positive integer, it's a negative integer. So you may be asked to compare whether not negative integer and whole number are same. Non-negative integer and whole number are same. Non-negative integer means this one and this one. Whole number is just missing. They both are equal. So you may be twisted in this way. Integers means will not talk about 2.1 or 2 by 3 in this format, which means the denominator, the numerator and denominator will have a common factor or the denominator will be exactly equal to 1. So you can present in just this form without decimals and without fractions. So if you present in fractions, so this will be called as 1 by 2 like 3 by this will be together called as rational numbers. So rational numbers will have integers and also fractions. Okay, now tell me, 4 by 2 is an integer or fraction? No, because it's presented in numerator by denominator form, you cannot call it as a fraction. Numerator by denominator form is present, but you can cancel it. You can write this as 2. So this is an integer. Okay, so you can say that probably 2 by 4 is a fraction. See, it is a numerator by denominator form, and this denominator is greater than the numerator. See, 4 is greater than 2. Okay, so fraction is actually, this is only the fraction. We say that 4 by 2 is a fraction, 2 by 4 is no. This is only the fraction, this is not a fraction. But because we are ratio form, because we are giving the numerator by denominator form, we are saying this is a fraction, but it's not actually a fraction. So rational numbers contain both integers and fractions. Okay. So for a rational number, we will have conditions. It should be present in the form p by q. Okay. You take these two examples. See, p by q form, numerator by denominator form. Q should not be equal to 0, the denominator should not be equal to 0, and P and Q both should be integers. Z is what you call as integer. Okay. Z plus positive integer, Z minus negative integer. Okay, and irrational number. Apart from these three conditions, if you find any other number, we call this as irrational number. Rational number is presented as Q, irrational number is presented as Q dash. Okay, and rational, irrational, everything put together is what you call as real numbers. And probably you can still extend this further along real numbers. You can talk about imaginary numbers also. Imaginary numbers will have the format P plus IQ, where I is imaginary. P will be real, Q will be real, but along with Q, you have to talk about I. Also, for this is complex numbers. Okay, again, we are not so much in depth with these concepts in our syllabus, so we are not covering this. Okay, so with the help of this one, let me go for the 13th problem. Shall I take over? 13. The set 2 power x is a positive rational number. So you know rational number is p by q form. P and q both are integers. Okay, and q not equal to 0. You have these three conditions here. X is a positive number. In addition to that, we have another one condition which is positive. See, these three conditions should be present for a rational number. And in my question is given positive. So this number should be a positive number. And we have to find the set of 2 power x. See, what is the set containing? It's represented as this way. Condition x is this one. So what's the nature of the element here? 2 power x. So for example, if I take x is equal to 1, I'll get 2 power x is equal to 2. If I take x is equal to 0, I'll get 2 power x is equal to 1. No, 2 power 0 this, okay. Then if I take x is equal to minus 1, you'll get 2 power minus 1, which is 1 by 2. The reverse. Okay. So if any number of x, I get different 2 power x. So x obviously happens to be an infinite set. So the 2 power x set also becomes an infinite set. Hope it is okay. If you want to make a note of anything, yes, you can please. Well, to continue. 14th one. Here, the structure is given as set of all 1 minus 1 minus and this minus 1 power x, which means this x is holding good only for minus 1. Okay. For all integral x, which means x is an integer, obviously it's an infinite set. So because it's an infinite set, you cannot have this as an infinite set. You need not have because the structure is different. So let me go over here. So 1 minus 1 power x. I need to give the value integer. They are not said as a positive integer or negative integer. Even 0 is also an integer. So let me take x is equal to 0. What happens? 1 minus 1 power 0 is value. Anything for 0 is 1. So 1 minus 1, 0. Okay. I think no doubt on this. Right. Let me proceed. X is equal to 1. 1 minus 1 power 1. Minus 1 power 1. Negative 1. So this will be 1 plus 1 which is equal to 2. Then x is equal to 2. 1 minus 1 power 2. Right. So 1 plus 1. Sorry, 1 minus 1. So this will become positive. Okay, this will become positive. This will become positive and you'll have minus. So 1 minus 1, 0. So I have taken for positive values. Now let me try for negative values. X is equal to minus 1. Yes, please help me. 1 minus 1 power minus 1. So this will be 1 minus 1 power minus 1 means it will go in the reverse form and power is odd. So this will be minus 1 by minus 1. Should not write this way. You have to write this as not minus 1 by minus 1. You have to write it as 1 by minus 1. Because we have a negative power, it will be reversed. So 1 by minus 1. So 1 and minus 1 minus 1 will become plus 1. So this is 1 plus 1, which is 2. Let me take x is equal to minus 2. Yes, 1 minus, yeah, 1 minus 1 power minus 2. So this will be 1 minus, let it be as it is. Then this has to be reversed. 1 by minus 1 power 2 minus 2, which becomes now plus 2. So this is 1 minus of 1. It's because this is becoming plus 1, right? So this becomes plus 1. So this is 1 minus 1, which is equal to 0. For any number of values, you can check for x is equal to 3, you can check for x is equal to minus 3. You will find that 0, 2, 0, 2, 0 only is repeated. So the answer is C. So the question looks as if it's showing us an infinite set, but my answer consists only of 0 and 2. So it's a finite set. Okay, so this is often repeated question in the exam. Yeah. Take one. E is a set of positive even number. O is a set of positive odd number. Okay. Even number, odd number. Then E union O's. We have everything. Positive and negative. Not positive and negative. It's positive only. But even and odd will be put together. So it will have one. So this will have like 2, 4, 6, etc. This will have like 1, 3, 5, etc. So if you club together, you'll get 1, 2, 3, 4, 5. So it's a natural. Okay. Shall I go for the next one? 16. R set is a It's a set of positive rational numbers. See, rational number can be positive, negative. Remember from this one, rational number, it can be positive because it's containing integers and also fraction. When we say integer, it can be positive integer, negative integer, and also zero. Okay, so we have here sets of positive rational number. Okay, which means positive integers it will have and positive fractions it will have. And E is a set of real numbers. Okay, which means it will have positive integer, it will have positive fraction, along with that it will have negative integer and negative fraction. So this seems to be like this R seems to be like a subset. Now the problem there is if you make a so this one and this one, either you can have this symbol or you can have this symbol. You have to be very keen. This symbol or this symbol. This is meant for proper subset. This is meant for subset. And you can be very clear that from this E, there will be at least one element extra. See, proper subset, there should be at least one element extra. Definitely it's containing complete set of negative fractions and negative integers. So this is going to be A. So not A, B. Okay? B is proper. Is it okay? Is it okay? Shall I go for the next one? Hope it's clear. 16th one. What is R? Let me clean the board. 1 second, let me clean the board. R is positive rational. From here, what is rational number? What is rational number? You'll have integers, you'll have fractions. Integer means you'll have negative integer, you'll have zero, you'll have positive integer. Fraction means, again, here in example, I have only positive fractions. Here you'll have negative fraction and also positive fraction. You'll not have zero here because zero is an integer. Okay, so in this angle, now we'll go for R, which has positive rational numbers, which will have positive integer and positive fraction. Hope it is okay till here? Again, when we talk about E, set of real numbers, we'll talk about positive integer. We'll talk about positive fraction. We'll talk about negative integer. We'll talk about negative fraction. And what about zero? Zero is neither positive nor negative. So we will talk about zero also in action to this. Okay. See, now we have some nature about X, sorry, R, and some nature about E, which means I can say it's a subset, proper subset. So I fill this dash line. Okay. So I need to fill this dash with this symbol or this symbol. When I use this symbol, it's a subset. When we are not talking about subset, proper subset, we will not use this one. If it's a subset, we use. But from this explanation, it's very clear. It's positive and positive integer and positive fraction. But we have set of negative integers and negative fraction in E. So definitely this negative will not be present over here. So I am having one element extra. So I can confidently write this as properly contained. So it's a proper subset. Is it clear now? Online homework is clear? If it is okay, shall I go for the next set? Or do you want to make a note of anything? Do you want to make a note of anything, please? It's okay. Yes, 17th one. 17th one. N set of natural numbers. So what do you mean by natural numbers? 1, 2, 3, so on. I set of positive integers. So positive integers. Let me refer this one. Natural numbers. Integers. Integers will be having both positive and negative. They say it's positive integers. So obviously this is containing only from this one. We will not talk about zero. So this is going to be equal set. Okay, so A is equal to, sorry, N is equal to, right? And 17th one was A. Is it okay? But what my problem here is sometimes in the material problem, I think CA foundations, clear CMA foundation, they represent as this one also. Okay, because whenever we have this symbol, it means both this one or this one. Is it right? Okay, which means it's proper subset and also subset. But definitely I'm not going to call this as proper subset. Okay, obviously this is the answer, so that's why I have taken A as answer. Okay, so in case this n is equal to I is not present, then C will be the answer. Don't go for none of these. Because whenever you talk about this one, this symbol, obviously it talks about this one or this one. So if A is not is the answer not given in the question, option is not given in the question, then the answer would be C. Don't go for none of this. Is it okay? Right? Because when you go for this picture work, natural numbers together with zeros, whole numbers together with negative is integer. In integer, we are talking about positive integer. So it happens to be they are representing natural numbers in terms of positive integer. But again, if you go for the structure wise, step by step hierarchy, it looks like the integer. That is this one is actually right. But more perfect is n is equal to I. So if this one is not given in the question, then you mark this as the answer. You have to be very keen on this. Okay. So shall I continue? Yeah. 18, 19 is a beautiful set. Here, I is a set of isosceles triangle and E is a set of equilateral triangles. So, what do you mean by triangle, first of all? What do you mean by triangle? So, you know, it's a triangle, so three-sided and three angles will be there. Okay. Equal number of angles and equal number of sides of this. The total number of angle, the degrees, will be 180 degrees. When we talk about the right angle triangle, this will have 90 degrees. So I should not make this type of a marking for 90 degrees is understood. We go for a small square box. It's 90 degrees. So this is right angle to triangle. Okay. If we talk about isosceles triangle, any two sides will be equal. Okay. Isosceles, we have to be very clear with the definition. Any two. Any two sides will be equal. If all the three sides are equal, okay, which means you'll have 60 degrees, and 60 degrees. Okay, equal degrees means obviously the sides will be equal. So this is equilateral. So from the name itself, we can say it's equal. So all the three sides are equal. Okay, all the three sides. If you have a key note on the condition, you'll find that any two is a simpler condition compared to all the three. When you say a triangle is equilateral, only if all the sides are equal. See, all the sides are very strong condition. When you say isosceles, any two sides are equal. Okay. Can we talk about an isosceles triangle and the equilateral triangle? If you say all the three sides are equal, obviously two sides are equal. So if you talk about equilateral triangle, obviously it's containing isosceles triangle. Is it okay? So yes, now tell the answer over here. I is a set of isosceles triangle. E is a set of equilateral triangle. So this is simple. Okay. I is a set of isosceles, E is a set of equilateral. So equilateral contains a very stronger condition. Whenever the condition is stronger, the set will be smaller because it has to contain all. So this is the answer. So what's the answer here? B. I contains E or E is contained in I. Answer is it okay? Is it okay? 19th. We found is a set of isosceles right angled triangle. See, two conditions. First condition isosceles. Second condition right angle. If the conditions are stronger, the set will be smaller. You can please make a note of here and there. If more number of conditions, obviously less number of elements. Less number of elements will be present in the set. Is it okay? Will be present in the set. Okay. Okay. See now, R, shall I continue now? R is a set of isosceles right angle. So isosceles is one condition, right angle is another condition. But what about I? Only isosceles. So this is going to be a big set and this is going to be a small set. Okay, so obviously R, I, so this is a big set. I'll be using this symbol. Okay, so answer is okay. Shall I go for next one? Next is often repeated question. That's why I included. The set contains n into n plus 1 by 2, where n is a positive integer. So n is positive integer. Obviously, integer is a infinite set. Positive integer is obviously going to be an infinite set only. So for each and every n, I will be having different values. N into n plus 1 by 2. I'll take x is equal to 1, I'll have a different value. I'll take x is 2, I'll have a different value. X is equal to 3, I'll take an x of what n. N is equal to 1, and I get completely different set of values. So obviously it's going to be an infinite set. So the answer here is infinity. So simple problems done. Simple problems, objective problems done. Now we have to go for word. Okay. So we'll continue after the break. So this is the problem. There is a survey shows that 40% of the Indians like grapes, where 68% like bananas. What percentage of the Indian like both? Which means and, which means intersection. What percentage of the Indians like both grapes and bananas? So we have the addition theorem, right? You remember the addition theorem? N of A union B is equal to N of A plus N of B minus N of A intersection. Okay. N of A is given. Okay, A we take it for grapes, B we take it for bananas. So N of A is given to be 40%. Okay. You have to remember. So why I have included this problem is it's given in percentages. So we take it as it is 40 plus 68 minus, actually you have to find this one. Only if you know this one, you can find this one. Because it's given in percentages, we take the total to be 100. Because there is nothing mentioned about the total. Survey of how many is taken is not being given. So the data looks like missing data, but because of percentage, we will take it as 100. Sometimes they will add a line saying a survey of 500 students or 500 public were taken. So in that, if it is given 40% for grapes, then you have to take 40% of 500. So then you'll not have 40 over here. See, because it's given in percentage and no data is given on the whole, we are taking it as 100 here. Okay, we have to make a note of it. This is quite important. So obviously, I have to get this value. So 100 minus 40 minus 68 will give you the value. Can I get the value? Actually, this will be minus. Okay, this will be minus n of A intersection. What's the value? Please publish 8. Please give your answer as percentage because we don't know the total value. Okay, so this is first question. First one is over. Shall I go for the next one? Shall I take over? Second problem. Problem number 2. In a class of 60 students, see, total is given. 40 students like math, 36 like science, and 24 like both the subjects, which means intersection and find the number of students who like math only, like science only, math or science, neither math or math. What is the 16? It's total number of students. Okay, so you're going to say this is union? No, you cannot still say because you take the Venn diagram. They say in the class of 60 students. So this 60 is over here. Okay, this is your math. This is your science. 40 students like math. So if I go for a small staging group, this full is math. So this is totally 40. Let me write it outside the circle. They talk about science, 36. And this common region, which I'm just scribbling here, this is 24. Find the number of students who like math only, which means this area alone. Okay, this is n minus s, right? So math only will be, you remember the formula which I'm using, n of m minus s is equal to n of m minus n of m intersection s. Okay, so this is my first one. So n of m is given to be 40 minus n of m intersection s is given to be 24. So the answer is 16. So the answer is 16. Likewise, science only, I'll go this dotted area. Let me continue over here. N of s minus n, which is n of s minus n of m intersection s, which is 34. 36 minus 24, which is 12. Okay, thank you. Either math or science. This display is union. See, this 60 is not union. This the whole set, universal set or sample space. So this is only union. So what's the formula we use for union? Addition theorem. Okay, so n of uh, a, I'm using a and m. M union is equal to n of m plus n of s minus n of m intersection s. N of m is 40, 36 minus 24. Shall I get the value? This is 24, 12, 52. Okay. So this value is 52. Okay. The last subdivision, neither math nor science. Remember the formula which we use for neither math nor science? Let me take out the page. The Venn diagram we were using over here. See, neither A nor B. We use A dash intersection B, or this we can say A union B, the whole dash. Okay. See now, if I talk about A and A dash, please check whether shall I write A dash as universal set minus A? Yes. So n of A dash will be the whole of universal set. So that will be the total n minus n of A. Am I right? So now I'm talking about A union B the whole dash. So this is the whole universal set n minus n of A union B. Okay. Let me have this in the earlier page. Over here. See, now what happens? N of A minus A union B has to be subtracted. What's the total n? 60. And n of A union B is 52, just we have found. So this is 8. So this falling outside A n. Okay, so this is 8. Again, this detailed working is not necessary, but we need to know what is happening over here about. See, here we are taking as n of s minus n of m intersection s. So you need to know all these. If you want to make a note of anything, yes, please come. If you're okay with the concept, you need not worry. If you want to make a note, you feel like, okay, this one has to be noted now, just do it. Okay. Take over. The last problem number 3, is given in a class of, let me go for the board. Yeah. In a class of 50 students appearing for an examination of ICWA from a center, 20 failed in accounts, 21 failed in maths, 27 failed in costing, 10 failed in both accounts and costing, 13 failed in mathematics and costing, and 7 failed in accounts and maths. Seems like a very easy problem. Actually, it's easy problem only. The one thing you have to make a note of here is the total is given. This is not the union. Okay, so total. Okay, so total is 50. So if I go for the Venn diagram, this will be my complete set. Okay, so this is 50. I don't know whether A union B union C is also 50. Okay, because see that this subdivision, students who have passed in all the three subjects. The full data is about fail and failure cases. But this question is having passed in all the three subjects. Okay, so I have to be very keen. So the data is talking about failed students, but the question is asked about passed students. Okay, so I have A, B, and C. So for mathematics, for costing, and for accounts. So first one accounts, then math, then costing. So 20 failed in accounts. They say just accounts. Check whether it's mentioned as only accounts or accounts. Only accounts means only A format. Here they are mentioning accounts. So I write it outside. You have to be very keen in this, okay? 21 failed in math. It's mentioning as math. Okay, it's not only math. So it's math. So let me write it outside. If I'm writing it outside, means it's meant for the whole circle. Then 27 failed in costing. Is it okay? 10 failed both in accounts and costing. So accounts and costing is this region. This full region is 10. Okay. Then 13 failed both in mathematics and costing. So this full region is 13. Okay. This is 10 and this is 13. Okay. And 7 failed both in maths and accounts. So this is 7. If 4 failed in all the three, so this complete region is 4. Now tell me, what is this one alone? 7 minus 4, 3. What is this one alone? 6. Am I right? This region alone is 6. What is this one? 13 minus 4, it is 9. Okay. Failure in accounts only you have to find. So you have to find this region. This is totally 20 minus this overall 3. This is overall 6 minus 4. See this minus 4 because I am taking here 3, I'll take this 4. So what's the value? Minus 10 minus 7. Okay. Students who passed in all the three subjects. Okay. Who passed in all the three subjects, which means they are asking about this area, which means neither A nor B nor C, which means A union B union C the whole dash, which means total minus N of A union B union C, where I can take the help of addition theorem. N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A or A intersection C, whatever it is, plus N of A intersection B intersection C. So let me get the value. N of A is 20. N of B is 21. That is accounts math and this one. Okay, costing. And this is 27. And this is, what is N of A intersection B? That is accounts and maths. 3 or 7? 7. See, this 3 is, I'm removing 4. That's why it's 3. Okay. So here 7. Minus B intersection C. That's math and costing. 30. You should not take 9. 9 is very much common to M and C, but we are talking about B and C together. Okay, so which means I'll talk about the common issue also. Minus 6 or 10. Thank you, ma'am. Plus 4. So can I get the final one? Yeah. This complete one is 42. This is, I think, 50. Yeah, 50 is given in the question. So 50 minus 42, which is 8. This is also repeated. The only thing you have to make a note here is the data talks about failures and failure students, but the question is about past students, which means they are talking about dash. Okay, sometimes they may be given with respect to past students and you may be asked to with respect to failed students. Okay. So from the material what I have shared is over. Now I'll go for one other extra problem. One or two problems I'll discuss. Okay. If you want to make a note of it, please. See, consider the following data. Tabular formula இருக்கு. இப்போ இது வந்து workers ரிலேட்டடான question. Workers வந்து ஷார்ட் டேர்ம் எம்ப்ளாய்டா இருப்பாங்க, மீடியம் டேர்ம் எம்ப்ளாய்டா இருக்கலாம், லாங் டேர்ம் எம்ப்ளாய்டா இருக்கலாம். ஓகே, பெர்மனன்ட் ஒர்க்கர்ஸ் இந்த ப்ரொபேஷனரி பீரியட்ல இருக்கிறாங்க அந்த மாதிரி. அண்ட் ஒர்க்கர்ஸோட நேச்சர்ஸ் பாத்தீங்கன்னா ஸ்கில்ட் அண்ட் டைரக்ட் ஒர்க்கரா இருக்கலாம், அன்ஸ்கில்ட் அண்ட் டைரக்ட் இருக்கலாம், ஸ்கில்ட் அண்ட் இன்டைரக்ட் இருக்கலாம், அன்ஸ்கில்ட் அண்ட் இன்டைரக்ட் இருக்கலாம். ஓகே, ஃபார் எக்ஸாம்பிள் ஸ்கில்ட் அண்ட் டைரக்ட் ஒர்க்கர் அப்படின்னு பாத்தீங்கன்னா ப்ராப்ளம் ப்ரொஃபஷன் ஏதாவது குவாலிஃபிகேஷன் இருக்கும் உங்களுக்கு. டைரக்ட் ஒர்க்கர்னா டைரக்டோட இப்போ ப்ராப்ளம் இந்த டேபிள் மேனுஃபேக்சர் பண்ணணும்னு வச்சுக்கோங்களேன், டைரக்டா டேபிளோட அசோசியேட் பண்ற ஒர்க்கா இருக்கும். இந்த டேபிள் நடுவில் ஸ்க்ரூ போடணும், அந்த ஸ்க்ரூ பண்றது வந்து டைரக்ட் ஒர்க் சொல்ல மாட்டோம், அது இன்டைரக்டா நடக்கிற ஒர்க். அதே மாதிரி வந்து அன்ஸ்கில்டு பெருசா ஒன்றும் வந்து குவாலிஃபிகேஷன்லாம் தேவையில்லை, சும்மா இந்த 2 3 ஒர்க் பண்ணணும், அது சொல்லி கொடுத்தா பண்ணிடுவாங்க. ஏன் இந்த மாதிரி பிரிக்கிறாங்கன்னா ஸ்கில்ட் அண்ட் அன்ஸ்கில்டு லேபருக்கு வந்து கம்ப்ளீட்டா கிரேடிங் வேற, அவங்களுக்கு உண்டான என்ன சொல்றது லைக் பே ஸ்கேல் வேற, எல்லாமே வேற வேறையா. இதை நோட் பண்ணணும். இந்த செட்டுக்கு நேம் தராங்க பாருங்களேன், SMLTI. எஸ்ங்கிறது ஷார்ட், எம்ங்கிறது மீடியம், எல்ங்கிறது லாங் டேர்ம், டிங்கிறது ஸ்கில்டு அண்ட் ஐங்கிறது இன்டைரக்ட் ரெஸ்பெக்டிவ்லின்னு சொல்லிட்டான். அப்ப இந்த ஆர்டர். அப்ப எஸ்ங்கிறது என்னது ஷார்ட் டேர்ம் ஒர்க்கர்ஸ், இவங்க எல்லாம் ஷார்ட் டேர்ம் ஒர்க்கர்ஸ். கரெக்டா? எத்தனை பேர்? 6 + 8 + 10 + 20 30 38 44 பேர் வந்து ஷார்ட் டேர்ம் ஒர்க்கர்ஸ். அண்டர்ஸ்டாண்ட்? நெக்ஸ்ட் வந்து எம். எம் வந்து மீடியம் டேர்ம் ஒர்க்கர்ஸ். நெக்ஸ்ட் வந்து எல், லாங் டேர்ம் ஒர்க்கர்ஸ். நெக்ஸ்ட் வந்து டி. டி இஸ் மென்ட் ஃபார் ஸ்கில்டு. ஏன்னா இங்க ஏற்கனவே ஒரு எஸ் வந்தனால அந்த டிவி நேம் பண்ணிட்டாங்க, அதனால நமக்கு கொஞ்சம் ரெஜிஸ்டர் ஆகணும். அண்ட் ஐங்கிறது இன்டைரக்ட். ஸோ இந்த மாதிரி நேம் பண்ணாங்க. அப்போ இன்டைரக்ட்னா கொஞ்சம் பாருங்க, இன்டைரக்ட்னா ப்ராபப்ளி எனக்கு இப்போ இவங்க எல்லாருமே வருவாங்க. எதெல்லாம் இன்டைரக்ட் பாருங்க, திஸ் இஸ் இன்டைரக்ட், திஸ் இஸ் இன்டைரக்ட். அப்போ இவங்க எல்லாருமே வருவாங்க, ரைட்? ஸோ இந்த மாதிரி பாக்ஸ் பண்ண தெரியணும், வேற ஒன்றும் இல்லை. ஃபைண்ட் த நம்பர் ஆஃப் ஒர்க்கர்ஸ் இன் செட் எம். அதான் ஃபர்ஸ்ட் 83rd கொஸ்டின். 84 வந்து இந்த கொஸ்டின்ல வந்து ஃபைண்ட் த நம்பர் ஆஃப் ஒர்க்கர்ஸ் இன் செட் எல் இன்டர்செக்ஷன் ஐ. இதெல்லாம் நீங்க ஈஸியா பண்ணிடுவீங்க ஒரு ப்ராக்டிஸ்க்காக, ஏன்னா எக்ஸாம் ஃபேஸ் பண்ண தெரியணும்ல எப்படி இருக்கும். ஸோ ட்ரை பண்றீங்களா? ஸோ 83 to 89. ஸோ அந்த முதல்ல இந்த டேபிளை பிரேக் பண்ண கத்துக்கோங்க. ஓகே, தென் மிச்ச ப்ராப்ளம்ஸ் எல்லாமே வந்து மேனேஜ் பண்ண முடியுதான்னு பாருங்க, இல்லைன்னா நான் ஹெல்ப் பண்றேன். ஓகே, எஸ் ப்ளீஸ். இது முடிஞ்சிச்சுன்னா ஃபினிஷ் த செஷன். மிச்சதெல்லாமே நீங்க ரிலாக்ஸா முடிச்சிடுங்க. ஆனா so probably tomorrow you have accounts only. அதனால வந்து you can sufficiently take today, Tuesday and Wednesday and complete it. Okay. So what is question number 83? You have to find the number of workers in set M. M means long, medium term. So 7 plus 10 plus 16 plus 9. What's the value? 42. Okay. 84th, you have to find L intersection I. L is long term, so this full common area with I. I is indirect, so 8. So 8 plus 0 is 42. 85, S intersection T intersection. S is short term, so this full content. T is T is skilled, I is indirect. So skilled and indirect. So 8. Sorry, 10. Right? So 10. Okay then. Yeah. Shall I go for 86? So till 85 is done. 86. So for 86. M union L. So medium, union, long term. So I'll get this full content. I'll get this full content. Okay. This is M union L. And we have T union I. T is T is skilled. So I'll get this full T. Union I. I is indirect. So this one also. Okay. Now how to get intersection. So intersection means I'll change the color. 7 and 3, 16 and 8 alone. Correct? So 7 plus 3 plus 16 plus 8. So it's 24, 34. Oh, there is no 34. I miss any value. It's M union L, which is medium long term. So the full area. Then T union I. T is skilled. Okay, skilled. So I'll get this part and also this part. Okay, it's right. So it's union. Have to consider both. Then I indirect. So it's 6, 7, 3, 10, 16, 8. Yes, I'll get both. Then I have to get intersection. Intersection means common. Okay. So it can be medium or long time worker. And T is skilled or indirect. Skilled or indirect. So skilled is this one. Indirect. Okay, I didn't consider this one. See, indirect I have here, right? So I did not consider. Sorry. So, so this is L M minus U. So this also will come, right? So I have to block this one also. Am I right? Okay. So 7, 3, 16, 8, 9, 0. Okay, right. Plus 9 and 0. So we got 34. 34 plus 9, 43. 43 is answer. You got. Okay. So till 86 you have done, right? 87, shall I continue? So I'll go for 87. 87. Consider the problem. Now find the number of workers in set S dash union, S dash intersection I, the whole dash. Let me go for this brackets first. S dash intersection I. S is short term. So S dash is this full box. Okay. And intersection I. I is indirect. So this one and this one. But I should not consider this one because dash is there. So let me go for small ticking work. So I'll have all these. Am I right? I'll have all these. Now I have to take S dash. S dash means this whole thing union. So I'll get 6, 8, 10, 27, 10, 3, 2. Am I right? S dash is this whole thing union this one. So I'll get everything I think. What's the total? What's the complete total? Can I get the complete total? 99. I want to check whether it's 99. Else I have to check once again. 99. Okay. So 87 is 99. Is it okay? Check the answer also. See, for 83 you got A, 84 you got B, 85 C, 86 D, 87 D, 99. Okay. So we have to do with 88 and 99. C and A is the answer. So I have to get C here and A here. So shall I work out 88? Find out which set of the pair has more workers. So which means we have to compare greater than or less than. So let me go for markings. Actually, we cannot do so much of scribbling in the question paper, but you can visualize. That's what I'm doing here. So it's S union. First, we focus on brackets. S union M is focused first. S is short term, and this is medium term. So I'll focus on this box, these two rows. Okay, then dash. So I should not consider this one. So for convenience sake, I'll make the ticking. I'll be considering only this one, right? Then L, same, right? So C is answer. Shall I go for 89? So 89. We have to consider this one separately and this one separately. So let me go for I intersection T the whole dash. So I intersection T the whole dash. I is indirect, T is screened. So it's I intersection T the whole dash. See, this is the area. Correct? What's the total? Can I get the total? It's 99 minus these three values. We should not add everything. This total is 99, right? 99 minus 10 minus 6. So I don't want this one, right? So it's 99 minus 10 minus 16 minus 8. 65. So this I intersection T the whole dash n of this value is 65. Okay, shall I continue, Papa? Next, go for next content with respect to S minus I intersection S the whole dash. So I intersection S the whole dash, which one I'll get? I is indirect, S is short term. Indirect and short term is this one. Okay, I am going to take dash. So dash means, okay, please focus here. If I have union and intersection, I can directly work out. But here I have S minus I intersection S dash. Okay, which means N of this one. Okay, N of this one. Which means I have to consider N of S. Remember, if it is A minus B, you take it as N of A minus B will be N of A minus N of A intersection B. Remember? So this is N of S minus N of S intersection I intersection S dash. Okay. Before going for the table, you just see logically. What is S intersection S dash? Null set. And you'll have I alone. So I is, I think, indirect. So this full of I, right? So N of S, what is N of S? 6 plus 8 plus 10 plus 20, 30, 38, 44. So 44 minus N of I. I is this complete total. No, you cannot get 63 here. Because I cannot have a negative value, right? Yes, I intersection S dash. So S intersection I intersection S dash. So, oh, sorry, this is null set. Okay, this is null set. Okay, so this is null set 0. Clear on the is it clear? So it's 44. So this one I'm getting 65, this one is 44, so this is the greater one. So what's the answer? Yeah, A. So this is done. So this question is often asked in the exam, like this table may be given, there will be asked to find this one alone or this one alone. Okay, so this is quite important one. So, so that's all about today.